Alright, so make sure you try it on your own first, and then come back later for answers. Alright, so looking at the first one, you want to find power, so you're definitely going to use your power equation, I equals V. You have your current, you have your voltage, you're going to multiply them together to get 4.8 watts. Make sure you are including your units. Next one, you want to find your current. So you got a couple different equations. My personal favorite, I like V equals IR. So I know if I want to get I by itself, I can divide by R on both sides. So I have I equals V R. I know my voltage is 9 volts. My resistance is 840 ohms. Plug that into a calculator, and you get 0.0107 amps. I would most likely have rounded it to 0.011, so this is going to make this round up, amps. Alright, then looking at 3, the equivalent resistance, you can see these two are in parallel, and this one's in series with both of them, so you want to do this section first. And that since they are in parallel, you're going to do 1 over plus 1 over the 50. Since you want to add fractions, these have to be the same on the top and the bottom. So you multiply by 200, or 2 on each side, so you get 2 over 100 plus a 100 gets you 3 over 100, and then do the reciprocal, so you get 100 divided by 3, so it would be 33.3, and then once you've done this, you now have 80 ohms left. This is now one circuit, which is 33.3. These are now in series, so now you can just add them, which will get you 3.3 ohms of total resistance. Alright, so we are still using the same problem from up there. So it was an 80 ohms, 100 ohms, and a 50 ohm. Alright, so you want to find two loop rules. So you can see we have one loop right here and a second loop here. So in our first loop, we start with our 24 volts, the initial. Subtract your first voltage. I'm going to call this area 1 and 2 and call this one 3. So subtract my volts from the 1, which is right here. Subtract your volts from the 2, which is right here, and this must equal 0. Alright, then my second one, again we start with 24 volts minus your first, it hits here first, goes around, and now is going to hit over here, which we called 3, and this must equal 0. Next we have two junctions. I'm still going to call this area 1, 2, 3, and 4. So going into this junction, we know that current 1 goes in, and then the ones that go out is 2 and 3. So total, together, 2 and 3 are going to equal your original main current. You now have this section over here 4. I just named it 4 because we're going in order. The things that go into this junction are 2 and 3. So currents 2 plus currents 3 add up will make the total large current from 4. Alright, then you can find our equivalent again if you hadn't realized it's the same problem as 3, so you get 0.3 ohms. That's from number 3, in case you couldn't tell. Alright, then you need to find your total current. When you use your total current, you want to use your total voltage and your total resistance. Our total voltage is at 24. Your total resistance is Req, or R equivalent. If you have that, you can now plug this in to V equals IR. So you know this is 24 volts, equals a current we don't know yet. The resistance is 113 ohms. Divide on both sides. and this will equal 0.21. I'm just going to round it here. Volts. Excuse me, amps. Alright, now I want to find the voltage and current through each resistor. So I'm going to try to make this as neatly and as small as possible. So this is where I'm going to put my grid. I got 1, 2, and 3. I'm going to start with my resistance, my current, my voltage. Alright, resistance in my first one, I'm going to use this 80 ohm resistor. Then I'm going to hit the 100 ohm. Then the 50 ohm. Alright, then we got to figure out how to find each one. So I know that for my current, the 80 gets the full current. Then from here you can now plug in V equals IR 0.21 times 80. This gives me about 16.9, so I'm going to round it up to 17 volts. And then say if I was finding power, you would just multiply these two together, which would give you about 3.6, again rounding, watts. Alright, on to the next one. Alright, we now know that I use 17 volts here. You can go back and plug this into your first equation. So 24 volts minus 17 gives you 7. That means there are 7 volts left over for your voltage here. If there's 7 volts left over here, there must also be, this is also 17, so this must also be 7 volts. Alright, from here you can go back and find your current. So you know our voltage, so V equals IR again, so we have 7 equals our current times our resistance, which is 100, so we'll divide by 100 both sides. You'll get 0.07 amps. Do the same thing, 50 divided by, 7 volts divided by our resistance of 50 will give you 0.14 amps. And if you wanted to go back and solve, this would be 0.49, and this would be double that, so 0.98, and this is again watts. Alright, on to the back page. So on your test, choose one. Right now I am going to go through both of them. Make sure you do write it in a well-organized paragraph on the test. I am not going to write it because writing with the tablet does not conducive to writing a full paragraph. Alright, so for the easy problem, you want to use your loop rule. So it means there's 2 loops, so whatever our voltage is here, this one gets the full voltage, and here it now has to share your voltage. So these share their voltage, this one gets the full voltage. Therefore, this one here at the bottom, C, will absolutely be the brightest, and then these two will be equally dim. In your explanation, focus on the total voltage for each bulb. Alright, looking at the next one is significantly harder, but if you try to check your loop rules, you'll see you have 3 loops. Each loop has 3 bulbs across it. That means they all have the same voltage. So instead, you need to look at your current. Alright, so while we're looking at the current, So they all have the same voltage. So while we're looking at the current, however, you can see, look, right here at A, you got 3 lines of it going through. You definitely have more current here. In fact, it gets the full current. Therefore, because it gets the full current, and power is equal to this, and for all this is constant, so this will determine brightness. So this is the full, it's the brightest. Alright, then we go look. So, on a very easy level, and this would probably get 9 out of your 10 points, is if you said B, D, and C were all the same, because you can see that your current goes 2 different ways, so they must get about half the current. However, notice when you draw your loops, where do you have more loops? C has more loops. There's less resistance there. That means that the less resistance, so if you look at this, your voltage is all the same. If you have less resistance, you must have a higher current. C is actually the next brightest. From here, so essentially they get half. So if you called B, C, and D on the same level, that gets most of your points. That's still an A. To get 100%, you'd have to say that C is slightly brighter due to that. Alright, then you can look at B and D would be the next brightest, and then E and F, because E and F get about half the current, a little over, but then it has to split again. So they're, probably at best going to get about 1/4 of the current. So this is really, really low. These are going to be by far the dimmest. Alright, hopefully you were listening and not just writing, because it looks like written gibberish. And I will be here, let me promise I will be here at 7:15, so I will leave my house at about 6:30. 6:45. Alright, I will see you tomorrow. Good luck studying.